Welcome, fellow high school grade 12 students and university hopefuls. Today, I am thrilled to bring you an exciting and informative YouTube video in collaboration with Gifted Academy Tutors, where we will delve into the world of MCV4U, Calculus and Vectors. Specifically, in this video, we'll be exploring Unit 1, Rates of Change, with a focus on Lesson 1 and the essential topic of prerequisite skills. Whether you're preparing for upcoming exams or simply looking to strengthen your understanding of this fundamental unit, you're in for a treat. At Gifted Academy Tutors, we are committed to empowering students to excel academically and reach their full potential, especially in complex subjects like calculus and vectors. But before we dive into the lesson, I want to ensure you have access to our wealth of educational resources. For personalized support and expert guidance, don't hesitate to reach out to us. Email: contact@giftedacademytutors.ca mobile, +1 416 846 5062. Website: giftedacademytutors.ca. Whether you're a high school student gearing up for university or an enthusiastic learner eager to expand your mathematical horizons, Gifted Academy Tutors is here to be your educational ally. So let's embark on this educational journey together. Subscribe to our channel, hit the notification bell, and get ready to delve into Unit 1, Rates of Change. Lesson 1, Prerequisite Skills of MCV4U, Calculus and Vectors. Stay tuned and let's unlock the gift of knowledge.
This skill is slope of a line. So if we are given a line which has two coordinates, so there is a line which we have two coordinates. The first coordinate is x1 y1 and the second coordinate is x2 y2. So if I have to calculate the coordinate with the coordinate, I have to calculate the slope. So how I can do that? So the slope of line is defined the difference of the y coordinate over difference of the x coordinate. So basically the slope is this angle from the x-axis. If this is the y-axis, this is x-axis. So the angle from the x-axis is the slope. So if we take an example, we have to calculate the slope of the points given. We have to calculate the slope of line. So how can we do that? To calculate the slope, we have to remember what is the formula for that. It is y2 minus y1 over x2 minus x1. So if we look at our coordinates, so this is x1 y1, this is x2 y2. So we have the y2 value is 1 and y1 value is 3 over x2 value is 4 minus x1 value is minus 2. So it becomes minus 2 over 6. So it is minus 2 over 6. So the slope is minus 1 over 3. So the next thing is that we are studying in this prerequisite is slope-intercept form of a line equation. So we are studying the slope intercept form of the equation of a line. In this topic, we have given a form of line. So the equation of line we can take so the equation of line is ax plus by plus c is equal to 0. So we can represent it in terms of y equal to minus a over bx plus minus c over b. So we can say it is mx plus capital C. So this m is represent as the slope and this represent the intercept. At y-axis. So this is the intercept form of a line. So if we have given an example, so we have an equation 2x minus 4y is equal to 7 and we have to calculate slope and y-intercept. What we can do that? Then we can change it into the standard form. So we can say it is 4y is equal to 2x minus 7 and y is equal to 2 over 4x minus 7 over 4. It is y equal to 1 over 2x plus minus 7 by 4. So if we compare it with the standard form is y equal to mx plus c, where m equal to half is the slope and c is equal to minus 7 by 4 is y intercept. So this is the standard form from where we can calculate the slope and the intercept. The next thing is the factoring. So if we have given a equation from which we can do the factors, like we have two x square minus x minus 1 is a equation and we have to do the factor of that. So how we can do that? So first we have to change it the single power term, like so this is like 2x square minus 1x minus 1. So here we have the 1 and minus sign and here we have the 2. So if we multiply this term with this, single term, so it becomes 2. So we have to do the factor of 2, so we can say it is 2 into 1 equal to 2. So this 1 we can write 2 minus 1, because these are two factors and we change them, and minus is because of this minus, because of minus sign. So we can write 2x square minus 2 minus 1 x minus 1. We expand it, it becomes minus 2x plus x minus 1. So if we can take common 2x, here it becomes minus 1, plus 1, here it becomes minus 1. So the factors are x minus 1, if we take common it becomes 2x plus 1. So this is the factor of the given equation. And the another thing that we can learn here is simplifying the expression. Simplifying rational expressions. So this is simple mathematics. If we have given a simplifying the rational expressions. So if we have given, we are taking an example how we can simplify it. So if we have an example like if we have 2 plus h and 1 minus half, which is 1 over 2. So what we can do, we can take the LCM or take both denominator, this one and this one, and here we will take this value 2 and the minus 2 plus h, which becomes minus h over 2 plus h. So this is the way how we can simplify the expression. The another thing is the function notation. In a function notation, if we are represent a function, there is a function of a variable x which is given in terms of ax square plus bx plus c, and we have to calculate this function at a value a. So what we have to do, we have to put x is equal to a in the function, or we can take here it is a1 in the function. So f(a1) will become a into a1 square plus b into a1 plus c. So similarly, if we take an example, we have given a function fx as 3x plus 12, and we have to calculate the value of 3 and f3. So here it is the value of x, so we put for f3 it is 3 into 3 plus 12, 9 plus 12 is 21. Now another thing is the domain of a function. To calculate the domain of a function, it is required to understand what is the domain. So the domain basically is the set of all the possible inputs for the function. So if we take the set of all the values that a function can take is called the domain of the function. So if we have a function y equal to fx, so the value of all the values of x that are finite and defined, that can define the function, all the values of x that are the possible inputs for fx is the domain of the function, the values of the set of the x. So like we have the values x1, x2, x3, x4, and we have function fx that turn the values in y1, y2, y3 and y4. So this is the domain. So this is the domain for the function f x to y. If we take an example, like the example is y equal to fx equal to 1 over x plus 1. So this function can take all the values, but x can take all real values, but 1 over 0 is not defined. So x plus 1 should not be 0 and x should not be minus 1. So x minus 1 is not in the domain of the fx. So the domain will be x belongs to minus infinite to infinite, but the value minus 1 should not be in the domain. So this is how we look at the domain. So these are the few prerequisites for this course. Hope you understand. With our first topic, rates of change and the slope of a curve. Now the rates of change what is the rate of change represents? It is the change in the value of any measurement. Example, it can be velocity, it can be the distance traveled, or destination, or anything with respect to time. For example, if we take the velocity of any car with respect to time, say at time 0 the velocity is 50 km per hour, and at a time of 10 seconds it is 100 km per hour. So if I ask what is the rate of change, so rate of change is how much is the change in the velocity, or how much is the change in the time. So it is v2 minus v1 over t2 minus t1. So here we can take it in meter per second also to make the unit same. In a mathematics or the physics, we have to take care of the units very well. So the rate of change is 50 over 10 meter per second, which is 5 meter per second square. So this is the rate of change. So basically it defines how much it is changing with respect to the time. Now we move to the next topic, which is the slope of a curve. In the slope of a curve, if we have a slope what is the slope? Basically, if we have a curve, so this is the curve, and at a particular point, if we want to measure the slope, so we draw a tangent to the point. Let's say this is the point and we draw a tangent. So this is the curve we have, and this is the tangent at the point where we want to measure the slope. So the slope basically at this point, we can take this point P. This is a curve, and this is x-axis, this is y-axis. So this tangent represents the slope of a curve at this point. If we want to measure the slope at this point, so we can see this is slope m, and we can define ms we can move delta y distance in the y direction and delta x distance in the x direction. So it is tangent of theta if this angle is theta. This is the angle theta and it is delta y over delta x. So delta y is the distance in y direction and delta x in the x direction, and we can say it is y2 minus y1 over x2 minus x1. So this is the point x1, x2. Corresponding in the y direction, this is the y1 and this is point y2. So this is how we measure the slope of a curve. Now we are solving few examples on this topic. So this is example 1. We have given the velocity for time period (21 less than t less than 30) is meter per second at 21 and 4186.7 meter per second at 30 seconds. So we have to calculate the slope. Or we can say the rate of change. The slope is basically defined the rate of change. So how we will do that? The solution of this question. So if we look, so we have a time t equal to 21 second at which we have the velocity which is 1436 meter per second. Similarly, at t equal to 30 second we have the velocity 4186.7 meter per second. So if we look, we have two times t1 and t2 here, and we have two velocity v1 and v2 here. So if we calculate the rate of change, we calculate slope, or the same thing, the rate of change, which is equal to change in the velocity over change in the time, v2 minus v1 over t2 minus t1. So v2 minus v1 defines the change in the velocity. We were at v1 velocity, then it increased to v2 after the time increases from t1 to t2. So rate of change comes 4186.7 minus 460. These two values are given, and the time values given are 30 and 21. So if we calculate these two values, we get 2650.7. The change in the velocity, and the time is 9, and if we divide it, we get 305.63 meter per second, or we can represent it as 305.63 meter per second square. So this is the rate of change or the slope for this question. We can take another example. Here we given there is a curve on which we have a point at which we have a tangent. This is point P, and we also have a point Q on the same line, and the coordinates of the point P and Q are given. It is 21, 1436, and the Q is 16.5 and 500. This is the x-axis, this is the y-axis. We have to calculate the slope at point P. So we have to calculate the slope at the point P. So how we can do that? So if you look at the question, we have given 2 points, the P and the Q, and with respect to P and Q, we have the value of y and x. So x1, x2 we have, y1, y2 we have. So this represents x2, y2, and this represents x1, y1. So how we can calculate the slope? So slope basically the tangent of theta. This angle is theta, so if this angle is theta, then tan theta is the slope. So we can calculate the slope, which we represent in terms of m. We can say it is tan theta, and it is the change in the y and change in the upon change in the x, and here it is y2 minus y1 over x2 minus x1. If we look what is y2 and what is y1, so it is y2 is 500 and y1 is 1436, and what is x2? X2 is basically 16.5 and x1 is 21. So the difference is minus 936 over minus 4.5, and it is equal to 208. So this is the slope of a curve at point P. Now we are moving to our next topic. It is the rates of change using the equations. The rates of change using equations. So if we have an equation of the curve and we want to calculate the rate of change or the slope of the curve, So we can use the differentiation method to do that. Like we have a curve in x and y direction, and we have given some equation. This y equal to fx is the equation of this curve. And we want to calculate the slope of the curve at any point. So we take a particular point and we want to calculate the slope at this point. So slope at this point will be the differentiation, this is the point P, of a curve, the equation of the curve at this particular point, or we can say it is d over of fx over dx at particular point P. So if we have given an equation, so for example, so y equal to fx is an equation of a parabola like 4x, and we have to calculate slope at x equal to 4. So how we will do that? So the slope x equal to 4 is dy over dx at x equal to 4. So the slope will be d over dx. What is the y? Y value is x square plus 4x at x equal to 4. If we do the differentiation, so we can do the separately, we can differentiate x square plus we can differentiate separately the 4x, and we can substitute the value x equal to 4 after the differentiation. So the differentiation of the x square will be 2x plus the differentiation of 4x will be the 4, and we can put the x value as 4. It is 2 into 4 plus 4, it is 12. So basically slope or the rate of change, so this is slope, or we can also say it is the rate of change. This is at x equal to 4. So we can use the differentiation method to calculate the rate of change for any particular equation. So we can take one more example where we have a different variable. Here we have given the function, the velocity of a body is represented as, so the velocity is the function of time and it is represented as 1 over 12 180 minus t square, where v is velocity in meter per second, and t is time in seconds. So calculate rate of change at t equal to 5 seconds. So how can we do that? So we already have an equation of Vt, which is 1 over 12, 180 minus t square. To calculate the slope of the rate of change we can say it is the slope of the curve. We can say it is the slope also, equal to, it is a differentiation of the function with respect to the variable. This is the function or equation of curve, and this is the variable of that function. So it can be, the function can be y, function can be fx, or the variable can be t, a, b, c, or whatever variable we want to use it. So the rate of change is t over dt, and the function is 1 over 12, 180 minus t square, and we want to calculate it at t equal to 5. So if we do the differentiation, so 1 by 12 will come out because it is a constant, and the differentiation of a constant value will be 0, and similarly the differentiation of t square will be the 2t. So it becomes 1 over 12. This value becomes 0 because this value is a constant. So differentiation of constant will be 0, and the differentiation of 2t will be, t square will be 2t, and we have to put the value 5. So it becomes minus t over 6, and at t equal to 5. So the rate of change will comes out 5 over 6 at a particular point of t equal to 5 seconds. So this was the example to solve the rate of change problem using the equation. Now this is the method called the tangent method. Now we can study one more thing, the average rate of change. In the average rate of change, we are taking some duration, like we have the curve, at this curve we have few points, like this is point Q and this is point P. These both points are on the curve, and this line is not the tangent line. This line is passing from the both points of the curve, and if we take the slope of this line, this is called the secant PQ. This is not the tangent, this is the secant PQ, and the Q point is at x equal to B, and P point is x equal to A. So the points B and FP, because this curve is Fx, and P point is AFA. So this distance we can see represent B minus A, and this distance represents the change in the y value, which is FP minus FA. So the slope of secant is represent the average rate of change which is change in the y coordinate over change in the x coordinate. But here the x and y both coordinate x2 and x1 are on the curve in the tangent. We only had the one point on the curve and another point was on the line. So that is the difference between the tangent and the secant. Here the both points are on the curve. So it is y2 minus y1 over x2 minus x1, which is fp minus fa over b minus a. If we take the slight modification, if h represent the interval between 2 points on the x-axis, then we can say, so this is the interval, so we can say the h equal to b minus a, or we can represent b as a plus h. So we have the points x and x as a and a plus h. Similarly, the y points will be fa and fa plus h, because we change the b as a plus h, because h is the difference between the x-axis points. So here we can say the average rate of change is delta y over delta x, which is y2 minus y1 over x2 minus x1, and it is fa plus h minus fa over a plus h minus a, which is fa plus h minus fa over h. So this expression is known as the difference quotient. Here one more thing, if h equal to 0, so this expression is not defined, because we can't define something which is in denominator have a 0. So h should not be the 0, it must not be the 0, otherwise the rate of change is not defined. And one more thing that we can note here, this expression is called the difference quotient. So this is the difference quotient which we define as a tangent. So we can take an example of that, how we can solve the equation using the average rate of change. Okay, in this example we can say the statement a secant represents the average rate of change of an interval. This is the fact we know, that a secant represents the average rate of change over an interval. The expression for estimating the slope of the secant can be obtained by writing the difference quotient which is delta y over delta x equal to fa plus h minus fa over h. Okay, this is the statement which is given, that a secant represents the average rate of change over an interval, and the expression for the estimating the slope of a secant can be obtained by writing the difference quotient. So this is the slope value. Here we have given a value of a function s, which has the variable t is 90 minus 4.9 t square, and we have to calculate the average rate of change for value of the interval h. Calculate average rate of change for interval h. So we can solve this using the formula which is given us, or we know this formula. So the solution is, we know the average rate of change which is basically delta y over delta x is f a plus h minus fa over h. So here we have the function s a plus h minus se over h. So if we put the a plus h in the function, we get 90 minus 4.9 a plus h square minus 90 minus 4.9 a square over h. So we can open this expression, it becomes 90 minus 4.9 a square plus 2ah plus h square minus 90 plus 4.9 a square over h. If we further solve it, we get minus 4.9 a square minus 2 into 4.9 into ah minus h square plus 4.9 a square over h, which gives us 9.8 ah, which has the sign minus h square over h. If we divide by the h, we get minus 9.8 a minus h. So this is the average rate of change of a curve, and we use the different quotient method. We have the equation, we remember it. This is all the statements are given. This is the question basically, and we use the formula and solve it, and we get the average rate of change. Now in this question, if we have the value of a equal to 1 and h equal to 2, so we have to calculate the value of delta y over delta x. So if we have the a equal to 1 and h equal to 2, so we have the expression of delta y over delta x, which is minus 9.8 a minus h. So we can substitute the value of a, which is 1, minus the value of h is 2, so it comes out to be, so it comes out minus 9.8 minus 2 minus 11.8. So here we missed one thing. Basically, when we multiply this value here, so it becomes 4.9 h square, and here it is 4.9 h square, 4.9 h, so it becomes 4.9 h, 4.9 h. So you can try to solve it by yourself. H is 2, so it becomes minus 19.6. So you can do calculation by yourself. You can try it and solve it. Now we can solve few more examples. So we are taking an example, another example, to calculate the average rate of change. So in this example, we have to determine the average rate of change from x equal to minus 3 to x equal to 2 for each function. So we are taking first the example A, which we have the expression of y as x square plus 3x, and the rate of change from x equal to minus 3 to x equal to 2. So we have the two values of x. We can say that x1 equal to minus 3 and x2 equal to 2. For corresponding x, we have the y value. Y at minus 3 will be minus 3 square plus 3x. We are just substituting the value of x into the function, which we get minus 3 square is equal to 9, minus 9 equal to 0. and y at 2 is equal to 2 square plus 3 into 2 is 4 plus 6 is 10. To calculate the average rate of change, we can say it is delta y over delta x. So change in the y is y at 2 minus y at minus 3 over change in the x is x2 minus x1, which is 0 minus 10 over 2 minus minus 3, which is minus 10 over 5. So delta y over delta x, which is average rate of change, is minus 2. Oh, it is basically 10 minus 0. So y2 is 10 and y3 is 0. So it is almost to plus 2 actually. In the next example, we have y equal to 2x minus 1. We have the value of x1 as minus 3 and x2 as 2. So we can calculate the average rate of change, which is delta y over delta x, is y2 minus y1 over x2 minus x1, which is y at 2 minus y at minus 3 over 2 minus minus 3, which is 2 into 2 minus 1 minus 2 into minus 3 minus 1 over 5, because 2 minus minus 3 becomes the 5. So delta y over delta x is come out as, it is 4 minus minus 7 over 5. So delta y over delta x is 11 over 5. So this is the average rate of change for this function. We can take one more example. In this example, the price of one share in a technology company at a time t in years can be given by a function pt, which is the function is given to us, and the time duration is also given. So we have to determine the average rate of change of the price of share between 4 and 12. So we have the equation of the function, we have the time duration. So we have a time t1 as 4 and t2 as 12 year. We have function pt as minus t square plus 16t plus 3. It is valid for the duration 0 to 16 year, and our both times are valid in this duration. So this is the reason why it is given, because this function is valid only for this reason, and our both the times are in this reason. Now what we have to do, we have to calculate the average rate of change. So average rate of change is delta y over delta x. We can say it is p at t2 minus p at t1 over t2 minus t1. So we can say it is p12 minus p4 over 12 minus 4. We can substitute the value 12 in the given equation, and what we will get is minus 12 square plus 16 multiplied by 12 plus 3 minus 4 square plus 16 multiplied 4 plus 3 over 12 minus 4. If we calculate these values, so we will get minus 144 plus 192 plus 3 minus 16 plus 64 plus 3 over 8. Now it is 51 minus 51 over 8, which comes out to 0. So the average rate of change for this stroke is the 0, or we can say no change, or average rate of change equal to 0.
Thank you for watching. Thank you so much for joining us on this educational journey through Grade 12 University Mathematics, MCV4U, also known as Calculus and Vectors. We hope this video has been helpful in enhancing your understanding and confidence in this subject. At Gifted Academy Tutors, we are dedicated to supporting your academic success and fostering a love for learning. Remember, learning is a continuous process, and we encourage you to keep exploring, asking questions, and seeking knowledge. If you enjoyed this video and found it beneficial, please give it a thumbs up and consider subscribing to our channel for more educational content. Your support means the world to us, and it motivates us to create even more valuable resources for you. If you have any questions or need further assistance, don't hesitate to reach out to us through our email at contact@giftedacademytutors.ca or give us a call at 416-846-5062. We are always here to help you succeed. Stay curious, stay inspired, and keep striving for excellence in your academic journey. Thank you once again for being a part of our learning community. Together, let's continue to unlock the gift of knowledge. Website, giftedacademytutors.ca,